Now we are going to see the power transistor. That BJT. BJT means bipolar junction transistor. Why we are calling it as bipolar? Because it carries two charges. Okay. So it is known as bipolar junction transistor. There are two types of transistor, that is NPN and PNP. Okay, this is NPN BJT. This one is PNP BJT. Here there are three terminals: collector, base, emitter. Here also base, collector, emitter. The current flow from in NPN BJT, the current flow from collector to emitter. In PNP BJT, the current flows from emitter to collector. Okay, when the current starts flowing, when base emitter drive is applied. I mean, base emitter junction is forward bias, the current starts flowing. Okay, when the to turn on the BJT, we need to apply base emitter drive. Okay, when we remove the base emitter drive, the BJT turns off. But here, like SCR, we don't want any commutating circuits to turn off the BJT. Okay, that is the advantage of the BJT. Then here we'll see the structure of the power transistor. This is the cross-sectional area of NPN transistor. So there are regions like N plus, N minus, P plus, N plus. The N plus region is heavily doped. The doping level is 10 to the power 19 per centimeter cube. N minus region is lightly doped, that is 10 to the power 14 by centimeter cube. P plus region again moderately doped, that is 10 to the power 15 per centimeter cube. And again N plus region, I mean in the emitter region, N plus region is heavily doped, that is doping level is 10 to the power 19 per centimeter cube. Here one thing we have to notice that collector region is classified into two different regions, that is collector region and collector drift region. Okay, the thickness of the base can vary from 5 to 20 micrometer. But if the thickness of the base is very small, then it is good for the amplification properties. That is, we can use the transistor to amplify to get the amplification properties. But if the thickness of the base is very small, it will affect the reverse breakdown capabilities. So we should take care in that. Then after that, you know, already I explained in the diode in the drift region what will happen, because the holes are injected into the drift region from P plus area. Then electrons are introduced into the drift region from N plus region. Okay, here the electrons and holes make a pair. Some free electrons are also there. They will get kinetic energy, so they knock off other atoms to release the electrons. That's what happening in the drift region. Okay. Then next we will see the steady state characteristics of the power transistor. Steady state characteristics of power transistor are also known as output characteristics of the power transistor. Here, the graph is plotted between IC and VCE. IC means collector current, VCE means collector emitter voltage. Okay, the graph is plotted between IC and VCE for varying levels of IB, that is for varying levels of base current. Initially, the base current is kept as 0. Okay, so we'll get this region is known as cutoff region. That means transistor is off in this region. Okay, then slowly they are increasing the base current IB1, IB2. That's why for your understanding purpose, I have written IB5 is greater than IB4, is greater than IB3, is greater than IB2. Okay, like that it will go. Here, the center region, no, the center region is known as active region. Okay, here this region is known as quasi-saturation region. Then this part is known as hard saturation region. So there are four regions, that is cutoff region, active region, quasi-saturation region, and hard saturation region. Quasi-saturation region means nothing but it is in the middle, it is in between the hard saturation and active region. So it is known as quasi-saturation region. Okay, so in active region, transistor acts as an amplifier. Okay, so active region is also known as linear region. In saturation region, transistor acts as a closed switch. But in cutoff region, transistor acts as an open switch. Majority carriers of the NPN transistor are electrons. Here one thing I have given. In saturation region, what happened? Both junctions, that is collector base junction and base emitter junction, are made forward biased. Okay, so that is the saturation region. That's why it acts as a closed switch. But in cutoff region, collector base junction is reverse biased, but base emitter junction is forward biased. So it acts as um, open switch in cutoff region. Okay. In active region, they act as an amplifier. As I told earlier, if the thickness of the base region is very small, then it is very good for the amplification properties. Okay. Then we'll see the merits of BJT. We have small turn on turn off times. Okay, so it is good that we can use it for higher frequencies. Then they have small turn on losses. Base drive has full control over the operation of the BJT, because if base emitter drive is removed, then immediately it will come to the turn off mode. They do not require commutating circuits, but for like SCR, they don't need any other commutation circuits to turn off it. BJT is a bipolar device, that is, it carries both the charges. Demerits: drive circuit of the BJT is very complex. Then storage charge in base reduces switching frequency. Okay, that is, in the if base storage saturation storage current in the base is very high, then it reduces the switching frequency. That is, switching frequency means the between on and off. Then negative temperature coefficient creates problem while paralleling them. Okay, that is, these are the demerits. Then application, as usual, they are used in SMPS, that is switch mode power supply, bridge inverter, DC-DC converter, that is nothing but choppers. Then they are used in power factor correction technique. Okay, now we'll see the switching characteristics of the BJT. Switching characteristics of the BJT. Here the connections are made as shown in the figure. IB means base current. IC is nothing but collector current. Okay, IE is emitter current. RBE means base emitter resistant. RCE means collector emitter resistance. Okay, two capacitance are there, CBE and CCB. Okay, what will happen that here when the base emitter drive is applied, I mean when the base emitter junction is forward biased, the base current starts flowing. The base current starts flowing, but the collector current should not respond immediately. So what is the reason for this? Because while the base current flows, this capacitance CBE gets charged. So the charge of the voltage of the CBE capacitance BE should reach 0.7 volt. If it reaches 0.7 volt, then the collector current starts rising. The collector current starts rising steadily to a steady state. Okay, so this time is known as this time 1 minute. So the turn on time is equal to time delay plus time rise. Time delay means the time delayed involved in getting the capacitance charged. That is the time delay. Then rise time means the collector current should reach the steady value. That time for that the time taken no that is known as rise time. So turn on here I have written I think turn on time is equal to time delay plus time rise. Time required to rise the collector current. Okay, to turn off the transistor, what we need to do? We need to remove the base emitter drive. That is, base emitter drive is made negative. So base current flows, negative current flows. Okay, but immediately collector current will not change. What will happen? It will take some more time because at that time the saturation of the base, that is the charges stored in base, are removed. Okay, that is the time required for removing the stored charge, that is known as TS. Then TF is nothing but the fall time which is required by the collector current to decay its current at least to the 10%. Okay, that is the fall current. Time required to fall current. Is it clear? So TF should be minimum. I mean the collector should decay its current at least to 10%. Okay, for that the time required is TF. So to turn off the BJT, the time required is falling time and storage time. Is the sum of the storage time and falling time. Okay, if in case if the base saturation is more, then it will take more time. Okay, that's it.